All right, last lesson of the chapter, section 2.7. We talked about this a little bit yesterday, but let's talk about it again today, and we'll get a little bit more detail. Let's talk about a distance first, okay? Let's just go in one direction. So if I was going to go from here to here, let's say I was right there, and then I wanted to go right here. Let's say we're on a number line. I'm just making this up. Well, not really. I'm looking at my notes. So let's say we go from -2 to +3. 2, -1, 0, 1, 2, 3. I'll put the numbers in, might as well. There we go. Everybody with me? So I am right here, but I want to get right here. So I want to find the distance I have to travel to get from -2 to +3. So I could just count, couldn't I? Yeah, so let's count. 1, 2, 3, 4, 5. So the distance would be what? 5, okay? 5 spaces, whatever. I don't know if these are inches or feet or yards or meters or centimeters, I don't know. But I went over 5 from -2 to 3. So you could just count. What if this number line, though, was like, I'm just making weird numbers up, -372, and I wanted to go up to +581. Would I sit there and put all those little marks on there and then count? No, that'd be ridiculous, wouldn't it? All right, so we got to have a better way than just counting. So how do I get from -2 to 3? How do I get a 5 out of that without just counting? I subtract. Very good. Okay, I subtract those two numbers. Does it matter what order we subtract them in? Well, it kind of doesn't if we do something to one of those numbers, and I'll show you what I'm talking about. So we could just subtract them. So what is this number? -2. And what do we say we're going to do? Subtract the number that we're going to end up at right there. Subtract a 3. So what do we get? What's -2 minus 3? -5. Now, would you ever tell somebody I traveled -5 meters or -5 yards or -5 miles? No. You would always just say what? 5 miles. It doesn't matter if you're going from here to here or from here to here, from -2 to 3 or from 3 to -2. It's still the same distance, isn't it? It's still 5, whatever it is, 5 feet, 5 miles, 5 inches. So what do I do with that negative? I can put it in absolute value, all right? So what's the absolute value of -5? It's just 5. Make sense? So does it matter what order we subtract them in? Not really, as long as you do what at the end of it? Just make it positive, right? And that's by using the absolute value. So I could have subtracted the other way. I could have started from 3. Let's do this one, right? From 3 to -2. I could have gone 3 and then subtract what? A -2. That's right. Don't just put 3 minus 2. 3 minus 2 would be this distance from here to here, wouldn't it? All right? But 3 minus what? -2. What is 3 minus -2? Positive. It's just 5. Technically, I could put it in absolute value, but what's it going to end up anyway? It's just going to end up 5. So it doesn't matter what order I subtract them in as long as I take the absolute value. Just take the positive version of it. You with me on that? All right, so that's how you find the distance. What about this? Let's grab this graph. What if it just wasn't left to right, horizontally? Now, we didn't talk about vertical, but vertical is the same thing, right? If it goes up and down, let's say I'm at 3 here and I need to go to -2 here, I still would just subtract, wouldn't I? All right, same thing. But what if we go diagonal? That's a little different. Okay. I tell you what, before I actually put some real numbers in there, I mean, you could just count and put some real numbers in here. Maybe we will after we do this. Let's say I wanted to go from there to there. I don't want the same 1, 2, 3, 4. 1, 2. Yeah, okay, that's good. Say what? Yeah, we're doing a diagonal line, exactly. All right. So I want to figure out how far is it from this point right here. Now, let's forget like exactly where it is. It's -3, -4, but I don't care about that, okay? It's just somewhere on the graph, all right? Let's just pretend that. Is that all right? So I want to figure out how far it is from this point to this point. Well, I'm going to call this point x1, y1. Now that 1 doesn't mean it's to a power. It just means this is my first x point, my first y point. So what do you think I'm going to call this point up here? If this is my first x and y, what is this going to be? My second one. So it's x2, comma, y2. You all right with that? All right, instead of calling it 4 different letters, right, I just called it xy on both of them. But on this one, that's x1, y1. This is x2, y2. It's not squared or anything. It's just to show a different point. That's all. Now watch this. Can I just count like I did on that -2 to 3? Can I just go, oh, that's 1, that's 2, that's 3, that's 4. Can I do that? No, because the distance from here to here is not the same as the distance from here to here, okay, horizontal or vertical. All right, so there's no way I could just count like I did earlier. All right, so I got to have a better way. So what I'm going to do is I'm going to break this up. Let's make this a little bit thicker so I can see it. What I'm going to do is go from here, this point, to right underneath the other point. Right there. Everybody okay with that? So if you're walking on this, pretend this is like a city block, right? You're walking a city block. You can't like walk across the buildings diagonally, can you? Most likely you would not be able to do that, all right? So you have to go down the roads. So if I was going to go from this place to this place, how would I get there? Well, I got to go the most efficient way anyway. All right, I could just go straight across until I get right under that building and then straight up that road all the way to there. Does that make sense? Or if I wanted to, I could have gone up this way and down and across that way. Either way would have been fine. But I'm just going to go this direction. You okay with me so far? All right, now let's go up and down. So now I'm here. Now how do I get to my destination? I just go straight up to here. Make sense? Okay. Let me change a couple things up here. Let's go back to white. All right. So here's the hardest part about this. We did this last year. I don't know if you remember doing this last year, but we did. What is that point right there? Again, don't count over 1, 2, 3, 4, 1, 2, 3, 4. I'm not talking about that. In terms of my x1, y1, x2, y2, where is this point? How far did I go over? x2, very good, because it's right under this one. You see that? Natalie, you the one that said that? Okay, so it's right under here, so that would be an x2. All right? Right, so I went over this far. How far is that? It's the same distance as that. Now, how far down did I go? y1, good, because this one, I went down, right? It's right across from this, isn't it? So it's the same y distance, so this would be a y1. Now, watch what we're going to do. Oops. Did I click on that blue one yet? No? Yeah, I guess I did. Yeah, that's blue. All right, good. Let's go make this go back to 1 point. All right, here we go. So what is the distance from this red one to that white one? Remember we talked about horizontal, didn't we? Okay. So the x1 minus what? The x2. Do you see that? All right. It's like that -2 to 3 thing that we did earlier. All right. So if I went from here to here, what is that distance? That distance, let's put it right here. That distance is x1 minus x2. I'll put it in parentheses. I kind of wrote inside of there, but you can write that in there, okay? That's x1 minus x2. Does that make sense? All right. Now, what is the distance from here to here? That would be y1 minus y2. Does it matter what order we subtract them in? No, as long as you take the positive length, okay? Everybody with me so far? What I'm trying to find I'm trying to come up with a formula for our distance of my red line. That's what I wanted to do originally, wasn't it? Find out how far from this point to this point, right? Just straight to it instead of going across and up. All right, I just want to find that distance. So watch what I have right now. I've got a right triangle, don't I? And I know the length of the blue one, kind of, right? x1 minus x2. And I know the length of the green one, kind of, y1 minus y2. So I want to use that to find the length of that red one. Well, what do I know about right triangles? I know a lot of things about right triangles, but here, let's kind of recreate this up here. That's it, you got it. I know if that's A and B, what would I call this? C. Do you remember Pythagorean theorem? Yeah, we did a lot of that in geometry. So what is that? Let's start with the C, is that all right? Most of the time we say a squared plus b squared equals c squared just to make it ABC. But let's start with the C. So what is c squared equal to? C squared equals a squared plus b squared. Agree? All right. So that's a very general thing, but now we're getting a little bit more specific. Let's take a look at what is our A and our B. What is our A? It's what? x1 minus x2. What is our B? y1 minus y2. Agreed? So how do I find the C? Now, instead of calling it C, we're trying to find what? We're trying to find the distance, okay? So why don't we call it D for distance? Is that all right? And I'll make it a capital D, just because that's what we like to do, okay? You could make it a small d, it doesn't make any difference, okay? We'll make it a capital D. So check this out. Let's use Pythagorean theorem now. Let's use this. So what was my C? It's D, but it's D what? It's D squared because I'm using Pythagorean theorem. You with me? Equals what? A squared. What was my A? That's it. It's x1 minus x2. But what do I have to do to that? Square it. And then plus, and then the b squared. What was my b? y1 minus y2. And what do I do to that? Why am I squaring this stuff? Because I'm using the Pythagorean theorem to find that length right there. Okay? That's what I'm trying to find. I'm trying to find that length. So that's what I'm doing right here. Now you could just keep it like that. A lot of people do. It's fine. But in most books, you'll see it written a little differently. And when we do it, we'll probably write it a little differently. So what if I wanted to get rid of that squared? I wanted to get D by itself. So I just wanted to get the distance by itself. Take the square root. That's right. If I square root this, it'll cancel out. See that? But then what do I got to do over here? Take the square root of that thing. So that right there is our distance formula. Let's write it nice and pretty without all the crossing out stuff. So D equals the square root. Now watch what I do. We did this yesterday a little bit, right? But I like to put the parentheses and squared and plus stuff first, and then I'll put in the x's and the y's. So here's what I like to do. I like to put parentheses squared plus parentheses squared. Now what goes in that first parentheses? The distance along the x. What is that? x1 minus x2. This is the distance along the y-axis, which is y1 minus y2, and bam, that is your distance formula. Okay? So that is the distance formula. And it's something that you need to memorize. You have to know this. There's no other way around it. Well, I guess there is. I guess you could just graph it, but that would take too long. This is the most efficient way to find the distance between 2 points. So they're going to actually give you this point right there. They'll give it to you with numbers, okay? They're not just going to give you x1, y, or x1, x2, or whatever, x1, y1, I should say. All right, and so we want to find the distance between those 2 points. That's what we're trying to do. Does that make sense? So that's distance formula. In my geometry class, a couple kids got mixed up. We're going to do midpoint in a minute here. They got confused between I think it was the slope and the distance formula, because remember the one where you had to know if the lines are perpendicular or parallel to each other? Do you remember doing that? And if they're parallel, the slopes are the same. If they're perpendicular, the slopes are negative reciprocals of each other. Well, this person did the distance formula instead of the slope formula. Okay, they had to find the slopes, and she did the distance. All right. Make sure that you keep it straight. You know which one does what and why you're using it. All right, it's very, very important, because of some of these problems, they kind of look the same, but you're finding two completely different things. Yes. Well, I made this. See, in order to get from there to there, I purposely went horizontally and vertically so that I could have a right triangle. Okay? So, yeah. So, well, yes, it will be, because you forced it to be. You made it a right triangle. All right? If I want to go from this point to this point, I made it a right triangle. So I went over and I went up. All right? I didn't go like slant this way out here and then slant this way, because again, I wouldn't be able to find that slanted distance. The whole idea of doing this is I know how to find the distance across horizontally. I know how to find the distance vertically. I put them together in a right triangle, and then that's going to give me my distance here. Yes. Yeah. 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 No, it's already. Now watch, it's a good question. Do we have to put it in an absolute value and make it positive? You don't, because what is that squared going to do for us? Because if I square a negative, it's always going to be positive, right? So does it matter what order I subtract the x's in? Doesn't make any difference. Why? Because the only difference is one's going to be positive, one's going to be negative, right? Like that -5, +5. But when I square it, if I square a -5, I still get +25. If I square a +5, I still get +25. Does that make sense? So you don't have to worry about the absolute value when it comes to this, because squaring it automatically will make that positive. And it needs to make it positive because I can't take the square root of a negative number anyway. Right? We'll talk more about that later this year. All right? So let's actually do this. Let's actually find the points. Instead of x1, y1, let's actually figure out what the points are. And let's just count. Let's use our graph. Right? Where is that point right here? 1, 2, 3, -3, 1, 2, 3, 4. So -3, 4. What's this point right here? Let's count. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4, 6. See what I'm doing? Just trying to find this point and find the length, the distance between them. Okay, that would be the length of that line segment, wouldn't it? What's that? -2? No, this point right here is in the first quadrant. This one? Yes, absolutely. I missed it. She's the only one that said anything? Nobody else is going to say anything? All right, it should be negative. That is correct. It's -3, -4. Thank you for that, because that would have really messed things up for me. All right? Everybody good? All right, so now I don't need that graph anymore, do I? I just found those 2 points. Now, most of the time, they might give you some problems where they give you a graph and they say find the distance between the, the length of that line. But most of the time, they're just going to give you 2 ordered pair. All right? They're going to give you 2 ordered pairs, and then you find the distance. So we need a distance formula. Do we have a distance formula? Yep, we got it right here. You know what the best way to memorize that distance formula is? Is to write it down every single problem where you have to use it. All right? So I'm going to do that. You could just put it at the top of your paper and just refer to it, but is that going to help you memorize it? I don't think it will. So let's just say this is number 1. I'm just making that up, okay? So this is number 1, and even though I have this written at the top of the paper, even though it's in my notes or whatever, okay, I'm still going to write it down every single time because I need to memorize it. So I'm going to write it down. Here's how I do it. Distance equals big old square root. I like to put my parentheses and my squareds in there, and that plus. And now, once I do that, I got it already set up, I just put my x's and y's in here, okay? So I'm going to write x1 minus x2, y1 minus y2. I would do that for every single problem. Why? just so that you can memorize it, right? The more you write it down, the easier it's going to be to memorize it. So that's what I would do. Now we can actually plug the numbers in. After a while, once you have this distance formula memorized, then you could just go right to this for your first step. Okay, but I would do this. This thing right here, I would write it down every single time. Even though you've written it down 3 or 4 times already, write it down a 5th and 6th and a 7th time. That way, it's going to make it easier to memorize. That's the way I think anyway. All right, so what are we going to do? We're going to subtract the x's. Does it matter what order we subtract the x's in? Doesn't make any difference. So I'm just going to go the first one minus the second one. So that's -3 minus +4. There you go. And let's do the y's. Here's the y's. This is a -4 minus what? A 6. And now I just do some math. The rest is just math. It's not even algebra. It's just reducing stuff, simplifying stuff. Keep that square root there. Don't forget about that. Let's do what's inside here. -3 minus 4. What is -3 minus 4? It's -7. And then we're going to square it. You might be able to do that in your head. You might be able to think, oh, -7 squared, that's 49, and then just write a 49 there. That'd be okay. I wouldn't mind that. But I'm just showing you every little step just so you know if you have to look back on your notes. -4 minus 6 is -10, and what are we doing with that? We're squaring that. Let's keep going. Keep the square root. -7 squared. Remember, squaring a negative just turns it into a positive. So it's just 7 squared. What's 7 squared? 49. Plus, what's -10 squared? Well, squaring a negative just makes it positive. What's 10 squared? 100. All right? And now, it's the square root of, add them up, that's easy, 149. I'm fine if you just leave it like that as your answer. Okay? Just leave it like that. You don't have to try to simplify it. You don't even have to write it as a decimal, right? No reason to. Just keep it like that. But just for fun, I'm going to put approximately. That's supposed to be a squiggly equals. I don't know what that is off the top of my head, but 149 square root. It's about 12.2. So it's approximately 12.2. Why is it approximately and not exactly 12.2? That's right. That decimal keeps on going forever. That's a irrational number, all right? And it just keeps on going forever. That's why I put a squiggle there. So if you went back to this, there's no way in the world you'd be able to count and say, oh, that's 12.2. Would you? No, I don't think so. All right? There's no way in the world that you could do that. But that's the length of this line right there. Okay? It's the square root of 149, or I'll put a squiggly equals 12.2 approximately, because the decimal keeps on going. It doesn't stop exactly at the 2. And that's how long that line would be. Does that make sense? All right. Okay. Enough of that. Let's talk midpoint. When's this over? 05? Okay. Is it? Not that I doubt you, but I'm going to look anyway. Yep. All right, let's talk midpoint. Let's do the same thing. We kind of talked about this yesterday, but we'll do it again. Let's say, we'll make this a little easier. I won't even put any negatives in there. We'll say we're at 2 right here and we're at 8 right there. Where would the middle, could be right there, where would the dead center be if this was 2 and this was 8? Think of it as you're driving down the highway and you're at mile marker 2 and your buddy is at mile marker 8. You guys want to meet halfway in between because neither one of you will want to drive the whole distance, right, to their house. So you want to meet right in between. Let's say there was a McDonald's. There's a McDonald's right there, okay? And you guys wanted to meet at McDonald's and it's exactly halfway. So what mile marker would you be at if you wanted to go halfway? Say it again. 8 minus 2 divided by 2? So 8 minus 2 is 6, divided by 2 is 3. Are you at mile marker 3? No, because 3 would be right here. That's a lot further away than 8 is. So it's not 8 minus 2. It's 8 plus 2. That's right. All right. Where would it be? It would be at mile marker 5. Why? Because it's 3 away from here, and it's what? 3 away from there. So how did you get that? How did you get a 5 out of a 2 and an 8? You took the 2 plus the 8, and what'd you do? Divided it by 2. Okay? So you don't subtract, you add. That's the difference between midpoint and the distance and the slope, right? For slopes, don't you subtract the x's and y's? Distance, you subtract the x's and y's. What do you do for midpoint? You add the x's and y's. So if I called this x1 and x2, how would I find the midpoint of that? x1 plus x2, what? Over 2. What if you went horizontally? Okay, what if you went from here to here? We'll call this y1 and we'll call this y2. How do I find where the middle's located? What do you think? Yeah, add the y1 and the y2 and do what to it? Divide it by 2, and that will give you that point dead in the middle. Everybody see that? Now, what if you had a diagonal line, right? That's what we did earlier. I'm not going to put the graph on here. What if we had a diagonal line? Again, you can't just count on the graph and find out where the midpoint is. Midpoint would be about right here. Okay. Okay, what if you wanted to find that midpoint right there? So what would you do? Let's use the same colors. Kind of the same thing as what we did earlier, right? You can't just count to there, so what are you going to do? I'm going to find the midpoint of this one, and then I'm going to find the midpoint of this one. Let's see if I got them. I missed it a little bit, but that's close enough. Just bring this in a little bit. There we go. And then once I find the midpoint of this, where would that be? That would be right here. And where is the midpoint of this one? It's right there. Whoops. There we go. So check this out. If I find the midpoint of the blue one, that's going to be the x part of that midpoint. Everybody see that? And then if I find the midpoint of the green one, and I come over here, check it out. It's going to hit exactly where I want. So how do I find the midpoint of the blue one? I take the x1 plus the what? The x2, and I divide it by 2. How do I find the midpoint of the green one? I take the y1 plus the y2 and divide it by 2. Once I get that, what's this point right here going to be? It's going to be the midpoint of both of them, exactly right. All right, and so I write it as a midpoint. Remember, this is a point. You're not finding the length, you're not finding how it slants or anything like that. You're actually finding a point. How do we always write a point? In what? As a ordered pair. That's right. Now, I say this over and over and over again, but still, I have people on quizzes and tests. I ask for the midpoint, and you guys do the distance formula, and you give me some number, all right? Or you give me a fraction, like a slope. This might come out to a fraction, but that's not the slope. You're finding a point, so you must have it in parentheses with a comma in between, okay? It has got to be an ordered pair. Everybody hear me on that? That's super important. So let's write the midpoint formula. Here it is. It's x1 plus x2 over 2. And then it's, I didn't give myself enough room. I'll just scooch that over. There we go. And then, what do we have? y1 plus y2 over 2. So that is how you find the midpoint. Let's do this. I always put it in a box Let's put it in a box. There we go. And there you go. That's your formula for midpoint. Again, you need to memorize it. Now, all that stuff that I did to get to it is just showing you how we got the midpoint formula. I think it's important for us to know. I could have just sat there and taken 5 minutes to show you how to do the distance and the midpoint, all right? But I think it's important to show you the background, where it comes from. How did somebody come up with those crazy letters and numbers? It kind of makes sense, doesn't it, on how we came up with that. So that's what it is. Again, it's something that you have to memorize. So here's what they're going to ask you to do. They're going to give you 2 ordered pairs, 2 points. And they're going to ask you to either find the distance, probably one set of problems. They're going to have to find the distance, then one set of problems you're going to have to find the midpoint. All right, let's just do the midpoint right now. So what if they give you -3, 4, and 1, 9? So this definitely looks like something that you would see on a quiz or a test. Find the midpoint is what they're going to ask you to do. Find the midpoint. I'll just shorthand it. So what are you going to do for every single problem that you have to find the midpoint? You're going to write down the what? We'll call this number 10. You're going to write down the formula. That's right. So write midpoint equals. And it gets a little boring. It gets a little monotonous, but it's going to help you memorize it if you don't have it memorized already. So x1 plus x2 over 2, comma, y1 plus y2 over 2. Remember, this is plus. Everybody see that? Again, a common mistake students make is they make that negative, because for slope it's minus, for distance it's minus, but for midpoint, what is it? It's plus. So make sure that you do that. I keep saying this, other students do this because I see what people do all the time. I'm probably thinking back to some of you guys that I had last year that put minus instead of plus. Okay? So now we do it. Let's put the stuff in. So midpoint equals. I like to do this. I like to put over 2, comma, over 2, and then we just put the numbers in. This time we add the x's together. So here's my x's right there, so I add them up. -3 plus 1. Now I take the y's and I add those up. 4 and 9. So 4 plus 9. All right? -3 plus 1 is -2 over 2. 4 plus 9 is what? 13 over 2. It's not quite simplified just yet. It's almost there. How am I going to write that? -1, comma, 13 over 2. And that's exactly how I would keep it. If you wanted to change this to a mixed number, that would be okay. I would give it to you. If you really wanted to change it to a decimal, I guess that would be okay. But why take the extra step and the extra opportunity to make a mistake? You know what I mean? Like if you said, oh, this is 5.5. And if you wrote 5.5 and you circle it, I'm marking it wrong, even though you might have done the work right here. So just keep it 13 over 2, as long as it's simplified like this. Okay, I had to simplify that to be a -1. So as long as it's simplified and reduced, it's fine just like that. Make sense? Okay, and that's all there is to section 2.7. Let me take a look to see what I assigned on this. 2.7. Oh, I broke this up into A and B, but I'm going to give them all to you. Yeah, they're so easy. So we're going to go 5 to 24. Plus it saves us a day. So I like to write this in red. So it's section 2.7. And we're going to do, so we're not going to have an A and a B. On the lesson plans, if you go to RenWeb or to Fax, it'll say A and B and split it up. But I want you to do all of them. All right, so it's 5 to 24. Okay? I don't know if the page number is page 95. Page 95. It really shouldn't take you too long. Once you get in the swing of this, it goes really quick. Boom, 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 boom. It shouldn't take you long at all. It's a few more problems that I would normally give, but I think you'll be okay. Yes, sir. Am I going to give you? Yeah, on the test, I believe on all of them, I just give you 2 ordered pairs. Okay? So I'll give you 2 ordered pairs. I could ask you to find the distance, or I could ask you to find the midpoint of those ordered pairs. So I don't think that I give you a graph and you have to find the distance. I think I always just give you the ordered pairs. Yeah.
If I write out like the formula, like see how you wrote out the formula there, and then I just give you the answer, because I can do it in my calculator.
No.
You want us to like?
You must show this. Now look, do you absolutely have to write that for every single problem? No, it's just a suggestion so that you can memorize the formulas, okay? But this right here, I need to see.
No, like if you just
Don't just put this as an answer.
yeah, put that first.
Yeah, put this stuff. Show me the numbers you're putting in it. Now, if you want to use a calculator right here to get to that, that's okay, I guess, but do you really need a calculator for that?
Yes.
No, not at all. Absolutely zero. You don't.
I do.
All right, well, if you keep saying that, I'm going to not let you use a calculator on the quiz or test. Okay? Actually, we're not having a quiz on this. Remember, this is only going to be on the test. Okay, you're not having a quiz on this. All right?
Formula, can I do the same thing? Like if I input all the numbers and I show you like what I'm putting into the calculator.
Yeah. Yeah, I'm letting you use a calculator, okay? I'm just saying, should you be able to do that without a calculator? Absolutely. And you should try. But if you want to do it to double check, I'm fine if you use a calculator for that. But I need to see this. Don't just write down the answer. If all you do is just write down the answer and don't show me any of this, I'm marking it wrong.
Are we only gonna have 2 problems, like for distance and midpoint?
I don't recall how many. We're going to review tomorrow, so I'll let you know tomorrow. Okay.